In this video, we're going to do some practice problems relating to the dilution equation. So let's go to our handout and try some out. Let's start with example 1. Water is added to 0.200 liters of 2.40 mole per liter ammonia solution until the final volume is 1.00 liters. What is the molar concentration of the final diluted solution? So we know we're dealing with a dilution style question because we're given an initial concentration and we're told that we're adding water to this solution with this initial concentration. We're adding water to it. When you add water to something, you're diluting it. And so we want to find what the new concentration is. So essentially, we have this solution. So this is not exactly how it's going to work. You're not going to do it in a beaker. You'll do it in a flask. But anyways, you have the solution of ammonia. And we say that it's a 2.40 mole per liter, same thing, solution. And we have 0.2 liters. So 0.200 liters of that solution, so about 200 mils. And so what we're told is that we're adding water to this solution until we get to a liter. So until we get to 1.0 liters. So we've added enough water to dilute this. We've added water, and so we've diluted it. And we want to find what the new concentration is. So once we've added the water, what is the new concentration? So essentially, we started off with this concentration. So let's write our given information. What we started off with was C1, which is 2.40 moles per liter. We started off with the volume of 0.200 liters. We told you that we ended up now having 1.00 liters. So we told you because we added water until you have a final volume of that. So that's our V2. And what we're asking you is what's the new concentration? And so before we even go ahead and solve this, I want you to think about, if it should be higher or lower than the initial. And so since you're adding water, hopefully you're starting to see this now, and I think you are, that if you're adding water, you're diluting it, it's becoming less concentrated. So the number should be smaller than C1. So let's see how we can figure that out using our little formula we have. So we know that C1, V1 is equal to C2, V2. We want to find C2 so we can rearrange. Essentially, we're sending the V2 to the other side. And that's going to become a division. Where you divide both sides by V2, you can look at it both ways. So C2 is going to be C1, V1 over V2. And we can plug in our numbers. So it's going to be the C1, which is 2.40 moles per liter. Don't forget to put your units. Multiplied by V1, which is 1.00 liters. Over V2, which is nope, made a mistake there. Let's erase that. See, sometimes it's very easy to make a mistake, so you always double check your work. Let's see. So we said V1 is 0.200 liters. That makes sense. And V2 is 1.00 liters. And so when you start canceling things out, you'll get liters canceled out here, liters canceled out here, and you're left with moles per liter. And so we'll get 2.4 times 0.2 divided by 1, 0.48 moles per liter. And it looks like we have 3 sig figs. So if we want 3 sig figs, we can say 0.480 moles per liter, or molar you can put instead. So instead of putting in moles per liter, you can write the big M like that, and it means the same thing. So therefore, the final concentration. For concentration, you can put square brackets like this around the word. So final concentration, that's what that means. The final concentration is approximately 0.480 molar, or moles per liter. Again, the square bracket system means concentration. So later on, we're going to see if I'm saying the concentration of sulfuric acid or of hydrochloric acid, I would say concentration of HCl, AQ. So the square brackets means I'm indicating the concentration. It's a nice tool that we use in chemistry, a nice shortcut we use in chemistry. So that was our first example of a dilution equation. That was example 1. In this video, we're also going to do example 2. So let's try this one out. You can try it out first, pause the video, and then check your answer to see that you're on the right track. And if you're not, just mark yourself and see where you went wrong so you can improve for next time. What is the final concentration when 350 mils of a 12 molar solution of hydrochloric acid is diluted to 2.5 liters? So this is a scenario where you have this acid and you have 350 mils of it, 350 mils of 12.0 molar hydrochloric acid. And now you're not supposed to add water to acid, so this is a bad drawing I'm doing. You're supposed to add water to acid. You're supposed to add acid to water, not the other way around. So just be careful with that safety piece, as we mentioned in the previous video. But essentially, just conceptually what we're doing is we're adding water to dilute until we get to a final volume of 2.5 liters. Okay, so we are diluting this. So we'd expect the final concentration that's lower than the initial concentration. So let's write out some information. What's our initial concentration? Initial means starting concentration. We're starting off with a very concentrated solution of hydrochloric acid, which is the HCl. So C1 is 12.0 moles per liter. V1, we're starting off with 350 mils, but we're rated as liters, 0.35 liters. And then we're going to dilute it to a new volume of 2.5 liters. And we want to find what the new concentration is going to be. So we know from our previous example that C2 is equal to C1 V1 over V2. And we're going to predict this to be smaller than C1 because you're diluting it. So let's go ahead and plug our numbers in. 12.0 moles per liter times volume 1, which is 0.35 liters, over 2.5 liters. Cross that out, and we get, let's plug this into our calculator, 12 times 0.35 divided by 2.5, 1.68 moles per liter, or let's go to our very fun sig figs here. 2 sig figs, 2 sig figs, 3 sig figs. 2 sig figs is the smallest, so approximately 1.7 moles per liter. And you can write your therefore statement. Therefore, the final concentration, isn't it nice to have shortcuts? Makes it so much easier. Final concentration is approximately 1.7 moles per liter. And so that's our sample problem done for example 2. Hopefully you are checking your work. You can make corrections as needed. Add some feedback to your own page about what you did right, what you did wrong, and retry the question until you no longer do the things you did wrong incorrectly. Make sure you can do them properly, and you'll apply that good habit to the next question that you'll see below. So in the next video, we're going to try a few more examples using the dilution equation, where we might ask you for different aspects of it, but it's still a similar approach.